everyone. So I'm Maxime Cordeil, for the one I haven't met yet. I'm a postdoc research fellow at Monash University. And I'm just going to talk a little bit of virtual reality opportunities for data visualization. So just a bit of background, what I do, what I've done before. So I work in the very broad field of human-computer interaction, which is basically concerned with improving the interactive loop between the user and the machine. So we all have tasks, and basically we don't want to spend hours finding information, retrieving stuff, and everything. So basically, the work of a human-computer interaction researcher is to make usable tools for people. And I also worked in information visualization, which is basically fetching big data sets and making interactive visual that makes sense. So just a bit of background, I've been doing my PhD on visualizing air traffic control data in France. So I've been producing various kinds of interactive visualization, so making big data visible and interactive. And I've been working on stuff such like occlusion problems in visualizations, being able to explore a large data set using pixel-based technique, and basically that's basically just the same picture with different. It's a bit, I have to say there and look at my fingers. And oh, that works. That's pretty cool. And yeah, reducing clutter using pixel-based technique. And just a year ago, changed, and I started using VR devices. When I started my postdoc, we were like, okay, so we all do this to the desktop visualization applications, and now let's try and see what happens with Oculus Rift and HTC Vive and everything, and so on and so on. So I sort of started continuing what I was doing before, doing aircraft trajectories visualization, simply by putting two people together in the same environment. So that's a picture, that's me and my colleague, and we are exploring virtual reality together. So I'm just going to give a brief outline of the talk. I'm just going to quickly introduce the various devices I've used for different studies and development, and then I just show a few interesting opportunities that VR can bring to data visualization. And then I will talk about a study that we've done recently comparing like big expensive VR devices and set up like caves to cheap HMDs for data visualization. And then I will have a very brief word on VR on the web because I'm not at all a web expert. I just started exploring that. Okay, so VR environments. So Matthias and myself have the pleasure to work with this very expensive environment. It's actually very cool. Yeah, it's a pleasure. Okay. So it's quite a big room with correct me if I'm wrong, but 80 HD screens with a tracking system, and basically you wear shutter glasses, polarized glasses, and you basically immersed in a very big virtual environment. And as you walk around, you sort of like walk in the room and walk through the graphics. And this system has like tracking systems, so it can track your head position, and basically you render the camera position from your actual position in the room, providing you the impression of actually walking in the forests, for example. And the other devices I've been playing with are HMDs. So, but I think we're familiar with HMDs here, pretty much everyone, I guess. Okay, anyway, I think that's all that you're not familiar with. So HMDs are these headsets that you put on your face, and that projects left and right image, slightly rotated to your left and right eyes, and creates the illusion of being immersed in the virtual environment. So just a quick word on why it is interesting to use these machines for data visualizations. So now they are usable. They have low latency tracking. They have a reasonable resolution. They are sort of have a horizontal 1080p per eye. They have a reasonable field of view, which is like you have less impression of looking through goggles, and basically they seem to be providing more immersive experience. And I skim through that very quickly. They also come with interesting hand tracking system. They are either image-based like Kinect and or the Leap Motion, which is this one over there, and basically just do computer vision and retrieve your hand rotation, quaternions, and whatever you like. Or you have more controller-based input into the virtual world, so you have like sort of controllers that are being tracked by the tracking systems. So yeah, all those technical features make it interesting to use these devices to explore the possibilities for visualization. So just very brief introduction. A common way to visualize multi-dimensional visualization is to make a 3D scatter plot, for example, to try and find the cluster and everything. So it's widely used in statistics, in science, in whatever. So what happens when you create a 3D scatter plot? You get like sort of dense areas, but you sort of want to see what's inside it. So you have like mouse and keyboard technique to control the transparency and everything. So what VR can allow us to do is, for example, put a headset on, render this scene from an Oculus Rift, use the Leap Motion, and basically use more natural interaction to push away the data. So that's just a simple sort of magic lens that push away data that are not in focus, for example, for your research. So it's pretty compelling, so we've tried it with a few people. We didn't lead a proper study yet on this, but which was just one of the first exploration doing this sort of rendering lots and lots of points and basically providing different interactive inputs to do that. Another brief example for visualization is this very, very complex process. So to explore multidimensional data, we can use self-organizing maps. Some people use self-organizing maps methods, which are very complex neural network algorithms that produce 2D visualization of high dimension data and sort of produce these 2D clustered images and everything. But the problem is this algorithm uses 3D topology initially, and then you need to project it back on 2D to make it usable. But then we're like, so yeah, by the way, that's a project we're doing with Florence here. And the question we ask is, is it really the right way to do using a 2D projection of a torus? Or actually, could we use a torus, a tangible torus, and compare if people can basically perceive better with a 3D, an actual 3D thing that you see in front of you. So you could do that by 3D printing torus, for example. But if you want to do a user test, you want to be able to, on the fly, change the texture on the torus to change different, to try different conditions. So a mini project you're working on is making the torus tangible. So you hold it in your hand, and you use, basically using an Arduino communication to Unity and OpenGL rendering, you can couple the rotation. I have a mini video to show you. Okay. All right. So what's happening here? Yep. All right. So I'm holding the torus and I'm wearing an Oculus Rift, and you see that we've put a mini Arduino in the thing with a gyroscope, and we're just coupling all our movements to what we're doing to the torus. And the thing is that while wearing the head-mounted display, like that, we can perceive what we're doing. It's really in front of us, and we can then use this sort of very immersive, tangible interactions to compare to classic 2D desktop interactions. Anyway, that was just another example of what another opportunity for that VR allows us to explore with data visualization. So I'm just gonna go back to the trajectory visualization and go quickly through that. Another interesting thing using VR and web and everything is you can bring experts close together. So when you have, for example, an accident or something very urgent that happens, what happens most of the time is you have experts converging going, or they're either video conferencing, or they take a plane and they go physically on place. So the problem with video conferencing, if you're trying to explain like complex 3D structural data, you can try, but it's a burden. It takes lots of cognitive efforts on both parts. On one part to describe the problem in 3D, and the other part to decipher the problem. Interesting thing is if you put complex data in a virtual environment shared on the internet, you can bring two people together, and I'm just going to show this scenario if I can play the video. So here we have, oh, sorry. Crap. All right. Is this playing? Okay. So here there is me and another expert, for example, and we're going to explore the trajectory data set together. And I've developed this platform.
On the right, you can see me through in the virtual
sorry, I'm just gonna.
environment. And if you look on the left, John, and now I see your avatar as well.
Sorry, really badly organized. All right. So here we are both on the same virtual environment. We are both wearing the Oculus Rift with two of these tracking trackers. And the thing is, something happened in the traffic, and so here we are in the same room, but of course we could be on the internet, right? We're connected on two different machines. And what I do is I'm going to explore the data set with John and explaining where the problem by sending in, for example, rendezvous points, and we say there, this trajectory is a problem and everything. And John is coming actually, he saw the message and he's going to the point where I am. And then I'm like, yeah, John, you see that's a big problem because blah, blah, blah. I'm not going to explain more what the problem is. It's just a scenario, right? So the thing is, using... so yeah, you look like that when you do virtual reality. But no one sees you because there's no webcam involved. Okay, so this is actually very, very powerful. And so for example, in the industry, there's been like past applications. I think it was with BMW. They used this virtual reality setup like 15 years ago, that they were worth million euros. Now they're worth $1,000, and you can basically reproduce your complex problem, just connect through the web, and invite your air traffic expert or whatever, discussing a problem. Okay, so I'm just gonna. So we wanted to explore these possibilities. We were like, is it really the same as being together in the same room, or really collaborating with two headsets in your head is maybe too weird? You misses lots of affordances, and you don't see the other people's facial expression, blah blah blah. Lots of hypotheses, and we just set up a very simple experiment. We made a very simple network visualization, and we asked a pair of participants, all together connected with an Oculus Rift to solve collaborative problems. So the only thing they could see in this environment was the other participant rostrum. So where the other participant is looking at, and where is that pointing at. So basically, we asked people, collaborative solve. Please find together the answer, or find the shortest path between the two green dots, or count the triangles. So it resulted in very, very interesting situation where people were like, yeah, it's there, and everything. It was really fun. And we compared that to the big cave. So basically, here we have two people in the same visual reality, and they're walking in the room. So it's, and there is more, they are more physically engaged and everything. They can see each other. Problem is though they don't share this. They can't share the same perspective because of the tracking system. So we were very interested in, can we do real serious collaborative visualization out of this kind of environment? And we looked at classic time errors and amount of speech exchange between people. We had two-sided hypotheses, like either people are gonna have like speech overload, or they're gonna not speak, or something like that. It has to be different. And we also recorded the actual path and where people were looking at in the cave and everything. So that allowed us to find what are the strategies. So here you see that there is an active person. That's the top view of the cave. And there is an active person, which is a red guy, and we have a guy which stays very, very still at the center of the cave. And then we looked at focus attention. We were thinking that in the Oculus Rift case, people would defocus more. But we found that, there's a slide. We found that there was not much differences in terms of error rate, because mainly due to our design, we left enough time to people to do their task. And surprisingly enough, they provided the same. The oral exchange between participants was not different at all. They were speaking basically 60% of the time to achieve their task. So, okay. The differences we found were that HND participants were much faster to achieve the task because they were not as physically immersed in the room. They were just in this virtual environment, sitting on a chair. And we also found that in the Rift, the head movements were much more balanced between the two participants. So that's just a vertical profile of head movements across time. So here we have two participants, and so we can see that the curves are sort of balanced. So two participants are looking at the visualization like this and like this. We're in the cave, because of the tracking system, we really clearly see the effect of the tracking system. We have a very passive viewer where we have a very, very active viewer. So this kind of stuff has interesting application on collaborative visualization. Is with these two HMDs, we basically notice that we have more equal ground participation probably because of the devices. So mini conclusion is, let's use Oculus Rift for collaborative visualization. Don't buy $2 million cave. I know it sounds silly, but if you were asking yourself, that's the mini conclusion. So just to finish with a few minutes, just finish with a very, very tiny word. I mainly use like basically C# wrappers and everything to do graphics, and I do I'm not really a web person, but I've been there a few times and I've seen Bosco's and Xavier's work, and I'm convinced that there is lots of things to do on the web. So I've started looking at what we can do on the web, and with virtual reality, there are like VR-ready build of Mozilla and Chrome. They support, I think they even support the Vive. There is 3JS, but I'm pretty sure everyone here knows that. They have a library to do VR using WebGL and everything. And if you need to connect your two people together across the world, blah, 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 you can use not JS, but yeah. And then I have a few examples, but maybe we can skip that. I can show you afterwards. So that's the end of my talk.